You see it every day, right? A headline pops up, there's a new market trend, a health report. We're just swimming in numbers. But how do you know what's actually meaningful and what's just, well, noise? That's what we're going to tackle today. We're going to build your personal toolkit for understanding the language of data. So let's get into it. So let's kick things off with a real world stat from the FDA. They found that 34%, that's more than a third, of retail stores weren't keeping fish at the right temperature. It's a really specific number. And yeah, it sounds pretty alarming, but it should also make you, a little curious. And that leads to the big question, doesn't it? How on earth could they know this without going to every single store in the entire country? That would be impossible. Well, that's where the magic comes in. And the answer, in one word, is statistics. So here's our game plan. We're going to build that toolkit piece by piece. First, we'll ask what even is statistics. Then we'll get into the difference between a population and a sample. After that, a parameter versus a statistic. Then we'll cover the two main branches of statistics. And finally, we're going to put it all together. All right, first up, what in the world is statistics? At its heart, it's really the science of making sense of information. It's how we turn a bunch of raw, kind of messy info into something clear that we can actually use. And everything, and I mean everything, starts right here with data. Data is just the raw material, all the facts, the figures, the survey answers. Think of it like this. It's all the ingredients you have sitting on your kitchen counter before you even start cooking. And statistics, well, that's the recipe. It's the science of taking all those ingredients, that raw data, and actually doing something with it. It's the whole process: collecting, organizing, analyzing, and then, and this is the most important part, interpreting it so we can make better decisions. Okay, section 2. This concept is absolutely crucial. It's one of the most fundamental ideas in all of statistics, understanding the difference between looking at the whole picture versus just a small snapshot. And that brings us to two of the most important words you're going to hear: population and sample. The population is the entire group you're interested in. Everybody, everything. The sample, on the other hand, is just a small piece of that population, a manageable chunk that you actually study. Let's make this visual. This big crowd here, that represents the whole population. It's every single person we want to learn something about. It's the complete set. And this smaller group we pulled out? Yep, that's our sample. Because we can't possibly talk to everyone in that huge crowd, we study this small group instead. It's our snapshot. It's our window into that bigger picture. This example really makes it click. Let's say a study is looking at job stress for U.S. employees. The population is all employees in the entire country. Think about how many millions of people that is. The sample, it's just the 834 people they actually surveyed. See the difference? Okay, awesome. Let's build on that. Now that we know the difference between a population and a sample, let's talk about the numbers we use to describe them. So we have two new words that line up perfectly with what we just learned. A parameter is a number that describes the entire population. A statistic is a number that describes the sample. And here it is. This is the single most useful trick to keep all this straight. It's the golden rule, seriously. Population goes with parameter. Sample goes with statistic. P with P, S with S. If you remember nothing else, remember that. Okay, on to section 4. We've got our data, we know who we're studying, we know what the numbers are called. So what? What can we actually do with all of this? Well, it turns out there are two main paths we can take. And those paths are called descriptive and inferential statistics. Descriptive is pretty much what it sounds like. It just describes the data you collected, making charts, finding averages. But inferential statistics, man, that's where the real power is. That's when we use the information from our little sample to make an educated guess, an inference, about the entire population. Let's check out an example. Here is a descriptive fact. A study of about 1,500 adults found that 18% of people in low-income households didn't use the internet. Now, that is simply a summary of what they found in their sample. It's a fact about that specific group. So here's the crucial question. What does that fact about our small sample tell us about the entire population of low-income households? What can we infer from that?
And this is the leap of inferential statistics. We take that one fact from our sample and we use it to draw a much broader conclusion. We infer that the pattern we saw in those 1,500 people likely holds true for the entire country. We're using our small, manageable snapshot to tell a story about the whole massive picture.
Okay, final section. We have built the toolkit, we've got our key definitions, our core concepts. Now, let's put it to the test and see how it works in the real world. You ready? Take a look at this statement. That number, 514, is it a parameter or a statistic? Think about it for a sec. Is that number describing a whole population or just a little sample? That one is a population parameter. And why? Because that average score of 514 is based on the entire freshman class. That's our whole population of interest. And what's the golden rule? Population goes with parameter, P with P. All right, let's try one more. A survey of about 9,400 people found they spent an average of 5.19 hours per day on leisure. What do you think? Is that 5.19 a parameter or a statistic? And that one is a sample statistic. The key word there is survey. A survey means you're only looking at a subset, a piece of the whole population. And a number describing a sample is a statistic. S goes with S. And there you have it. Just by understanding the difference between the whole picture and the snapshot you're looking at, you've built the foundation for making sense of any data that comes your way.